When we introduced the reactive principles, we talked about the fact that reactive systems are message-driven. They're based on a message-driven architecture. And we talked about those systems using asynchronous non-blocking messaging. So let's talk a little bit more about those messages and why they're important. So asynchronous non-blocking messaging allows us to decouple our system in time and failure. So it is a way of isolating our system. It means that services aren't dependent on the response from each other. So again, I think this is a place where it's helpful to think about this in terms of people. If you try to go about your day-to-day life, your job, in a synchronous manner, that means that if you need somebody to do something for you, you will go to them and you will say to them, hey, I need you to complete this task for me. Can you gather this information or complete this report or write this code or whatever it is? You will ask them to do that task. And then you're going to stand over their shoulder and wait for them to finish it. You're not going to continue doing your own work because if you do, then you're no longer being synchronous. You're going to sit there and wait for them to complete that work. And once they have completed that work, then you will take the results of that and go on about your business. Now, if you think about that from a productivity perspective, it's extremely inefficient. It basically means that you have two people doing the job of one person. The fact that you are standing over their shoulder watching means that you are unable to do anything, and therefore you might as well not even be there. We should just have one person doing all the work instead of two. So that's very inefficient. Now, if you flip that around and approach that from an asynchronous, non-blocking perspective, in that case, what you do is you go to the person and you say, hey, I need you to complete this task. Once you're complete, I'm going to be at my desk. Can you send me a message or something? Let me know that it's done, and then I can continue on. So then you go back to your desk and you continue to do whatever other work you have. You can check your email. You can do other meetings. You can do whatever it is you need to do. Now you've taken the problem and you've turned it into an asynchronous non-blocking problem. And that's far more efficient. We know that from our day-to-day life. We know that that's a better way to do things. And that's what we're trying to achieve with software. We want that asynchronous non-blocking messaging because it is more efficient. When it is asynchronous and non-blocking like that, it allows us to free up things like memory resources. It allows us to free up CPU resources. We're not occupying threads. All of these things can be put aside and used for other tasks. We're not stuck occupying, even something like a database lock. We're not stuck locked on the database while we wait for something to complete. So this frees us up to do a lot of other things. It also means that if a request to a service fails, the failure won't propagate. So if you have a service that does a synchronous request, then when that happens and you get a failure, you send a request to the other service, it doesn't respond. First off, you're stuck waiting for a response that isn't going to come. Eventually, you're going to time out, and then you're stuck failing. In the meantime, you've occupied all of these resources for something that never completed, it's a waste of time. By making it asynchronous, you send the request, you hope that a response will come back at some point. Maybe you keep checking occasionally, whatever the case may be, but you don't occupy those resources in the meantime. And if that failure does occur, then because of the fact that you've made it asynchronous, you'll hopefully have a way to deal with that failure. Maybe you request again or something at that point. But the point is, you're not going to just bubble that failure back to whoever requested something originally from you. Because the client isn't waiting for a response, it continues to operate normally. If other requests come in the meantime, you can just go ahead and do them. You're not going to have to worry about there not being enough memory because it's currently being occupied by a request that's stuck in limbo. You're not going to have to worry about a lock on the database that you left open while you waited for this response. All of those types of things go away when you build things in an asynchronous and non-blocking fashion. And as a result, we become more isolated in both time and failure. Our services are less likely to fail, they become less brittle, and they're not dependent on things to happen immediately. They allow for some time to happen. And that's a benefit. It results in systems that are going to be more robust.